All right. In the last tutorial, we showed how to generate this kind of strange geometry from a massing study. Looks like it's doing something pretty interesting, but I want a lot more control over what it's doing. So we're going to sell the last geometry, delete that, and we're going to ask Opus to build us a UI. Can you build a UI for this script that lets us control most of the parameters? That's going to do. Meanwhile, again, it's always nice being able to do something while the script's running. I'm going to go and just scale these down a little bit, move them over to the origin in anticipation of probably wanting to copy a whole lot of different variations on this. Another thing that we could do, which is pretty interesting, come to think of it, is we could do this testing ourselves, or we could do the testing just with Opus. So we could write another wrapper script that goes around this thing that just generates variations on the parameters and saves them to the viewport so that we could see, okay, here's what all the different variations do. That would actually be pretty interesting. So maybe we'll do that in the next tutorial video. But for now, we're just going to have a UI that lets us control things so we can understand what these parameters are and what they do. I think the main thing that we want is to just make it run a little bit faster to begin with, because it's probably doing quite a lot of calculations to make sure those lines don't intersect. Okay, we've rewritten the script. Let's hit run. Gonna save this as well. Generative design. All right, there's our seed curves. Nice, so we've got our UI. Divisions per seed curve. So I think this is one thing that's going to make this slow. So I'm going to turn this down to be sort of 20 for now, half the divisions. Iterations per side, let's change that. Let's make that just 5 for now. Base offset distance, minimum gap. Let's make that much larger. Let's make that 2. Direction both sides, yep, sure. Variation, wave frequency, wave amplitude, Z drift. Interesting. Let's make that 0. I don't know what that does. Collision avoidance, 8 push iterations. Okay, that probably is something we want to change as well. And then it's got us some options for center colors and edge colors. Nice. Let's run that. I'm expecting this to go much faster because we've turned down a lot of the settings. Interesting. And now it does also look like we've got much more interaction between all of these curves, which is pretty good. We've got a bit of a crazy tangle down the bottom there, which is also pretty crazy, and a bit of a crazy tangle up the top. So I think maybe this sort of crazy tangle is coming from the pushing these points away from one another, actually. Let's run this. I'm going to try running this on, so let's go cell last and just copy that over or move that over there. Let's see what it does if we just run it on a simple curve in plan. So run that again. Just one seed curve. We'll just leave everything as default. Cool, so we can see the offset now, and you can kind of also see how it is or isn't interacting. So let's try that again. And I'm going to increase the number of divisions. I'm going to decrease the number of offsets. I'm going to decrease that as well. We're going to increase that. We're going to increase that. And let's generate that and see what we get. Okay. Cool. Let's try making it 3D. See what we get. Again, I think we'll just try that, that, and crank that right up. Cool. So we do have some, you can see that next iteration is stacking and threading through the last one now. So with more points, we're getting a little bit more interaction, which is definitely what I had hoped for. So that's kind of cool. Let's try it with one more config. So I think we definitely need a lot of divisions and not many iterations, I think. And that can be one, and that can be one. I think we need more of these. And I don't know what that is, so let's make that 0, 0, just to see what we get. Okay, so we definitely needed more iterations. I would like to save these parameters because I need to otherwise remember. Let's make that, let's increase that quite a lot, but we're gonna only do it on, that's interesting, that doesn't, it's probably gonna break. Oh, okay, and offset the other side. Mm-hmm. Oh yeah, so then we can see what's happening. So with the flat offset, I think that's actually better. It's more controlled. We can see more what's going on rather than getting pushed around by a wave function or whatever it is. Seems a little bit more interesting to me. So I kind of like that. I think we're getting somewhere. So all I'm going to do now is let's run that with two curves. And I'm going to kind of want one to go inside of the other. I think that might be kind of interesting. Okay, let's try it with those. So we've got two seed curves. We're going to crank that right up. 1, 1, drop that, flat, bump up the collisions, and let's see how we go. It's weird how it loves doing these spirals, this script. Spiraling through itself, trying to spiral its way down. But I kind of like that. I think that's kind of a pretty weird form. So I'm going to keep that. That's going to be what we're going to keep working with. It's pretty bizarre. And we can carry on.